Hello guys. Um, okay, today we keep solving the question on Leetcode. That's today we got a reordered a power of two. Hmm, to a given an integer n, we reorder digits in any order. Okay, such as the leading digit is not zero. Okay, return two if and only if we can do this. So that the result number is power of two. Well, what does this mean? Okay, we got an integer n, and we're gonna reorder the digits. I understand it. So it can only be the power of two. If it's end with zero for sure, but the n here is so very small. It's about 9 digits. It's actually it's 9 digits. Yes, that's 9 digits. So we could try all the possible solution. More similar, we could try and multiple solution. You could have two methods here. The first one is you try on the permutation of the digits. Make sure the first digit is not the new number is not zero. It's not leading zero. So we check if that's the power of two in O1. As the yesterday problem, we can check it in O1. And the second way, instead of generate on the permutation, that's take you this factorial, 9 factorial, but it's still so small. It's factorial, factorial, yes. And the second way, you can try on the possible mm, power of 2 is may cost you, it may contain about 30 power of 2 digits in the range that's not exceed its value, and check if we could formulate that permutation based on the counting, Okay, so that's it. We need to count on the digits, so we want to check at the power of 0, 1 is or 2 or 4, 8, 16 or 22 or 64, something like that, and check if the given number maybe is less than this number. You could count 4, you got one as if one number, and 6 we got one number, and actually this is also have the same count, so that's the number. Okay, remember there's no leading digit, so the zero must be at the end, and we need to count it too. So let's implement this side. We need to create a count. Gonna use a counter of string n, maybe that's the, and we're gonna while actually the current digit size curve, the curve power 2 is like maybe it's 1, curve power 2 less than I will iterate until uh, actually this number it exceed that number. Right, so I'm gonna do something like this, and we check, we write function to check. Actually we can do it in this instead. uh, the count slide something like counter power 2, and you check if all the elements is the same with the 4. Actually we could do something like f. How we do it, length, the first check gonna just too nice to have two here, length, just fall from digits to from 0 to 9, and check if t if t not in count or t not in actually the by order of string with power 2 in a per count. So we're gonna do like it's not, we're not break this out. We're gonna do the flag here, two flag forms if flag. So we can actually we could return true. Sorry, so we can true here, we can return true. I always inform okay, we try IRE power 2. So in another case, if count these not equal to count these is flag false to break it out. That's a solution. Believe that solution. Uh, wonder about the time. Oh, wait a minute. All right, got it. So, I mean, if it don't exist in both, so it's okay. I gotta rewrite this if the in count and the in count, so we can do this, right? LF the in count the not in count. I mean, if the in count or the in sorry cur count and the in cur count, so it falls to because this case both exist and in another case both must not exist. So else if one of two exists, so it must be break, right? And that's it. Wait a minute. This number could be reordered into a number? That's crazy. Wow, we could ignore zeros. It's so I understand the problem that the leading zero is not a step, but it's gonna become remove on the first zero. So obviously we need to check it. We can ignore on the number zero and the number zero. So we fall from one. And the last check, we need to check if the new number have more zero. It's like the actually if we're gonna check if zero in the count and if zero in per count, so we need to check if count get zero or is plus within zero, it must be greater than or equal to count zero for sure. False. If less than, it must be false because we could remove zero from the original digit, but we can't remove from the what the does it mean? All right, so whatever we do like this. Must be true. What? First answer is 1. The first answer is 1. And I check the 1 with 10. And the count of the original less than, so it will be false. But actually it can't be. So why is written false here? What do you mean? Yeah, because so is also it must be true, right? What? So it's true. Why you zero less than zero? It can't be. So the plus is still true, but why? So sorry, just God, can't believe. No leading zero, no leading zero. So the formula must be true. It must be written false anyway. So why is written true? I need to check it out. Actually, it's because the zero we check here. Look, it's so true, man. That's one. How you could pass it with the zero gonna be here and check if the in count and the in per count is can't appear. No, it must be it doesn't. So it must be do this and false for sure. But why? What? 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 Are you kidding me? Oh, I see my mistake. Sorry, so sorry about it. You know what? A digit is not, its character is not digit. Why? Why? Forgot it. Use Python make me forgot about time assessment. The algorithms might be true for the beginning, but do some overthink. Wait a minute. AI did. Well, just check it out. Some silly mistake. No way. No way. Yeah. You see? I promised you. This time must be true. About the time complexity, you can see it's about only 30 minutes at 30 time to iterate on the power 2. And the check is gonna take you 9 or 10. Iterate from 0 to 10 into 9, so it's about 01. For sure it's 01. Oh, that's it. That's my solution. That's 01. Check it out, the first one. Oh, that's it. Well, this way must be ah much better. Okay, I will like to implement this again. Mm. If Photoshop, that's amazing. Wow, so simple. Why so simple, man? Amazing. Amazing. Huh.